Hi everyone, today we're learning about box and whisker plots, or more simply, box plots. They're a type of graph that is used to organize data. And these are the two questions we'll be addressing throughout the lesson. What do you remember about box and whisker plots, if anything, because you really did do it in 7th grade, I think? And what information about a data set do they display? So a box and whisker plot is used for a set of data to display the following: minimum, maximum, median, Q1 and Q3, which are the first and third quartiles. We'll talk about them in a second, and outliers. So we are not really going to talk about outliers in this lesson. We're going to focus on these 5 numbers, and they are called the 5-number summary. Sometimes you'll be asked to get the 5-number summary for a set of data. That's what they're referring to. Okay. Excuse me. So a couple of definitions here, which will become clearer as we do the example. The first quartile is the median of the first half of the data. So imagine your data, all your numbers arranged in order. And if you look just at the first half of your data and take the median of that, that's your first quartile. And you can guess what the third quartile is. That would be the median of the second half of the data. And the reason this is Q3 is that you have also the median of the whole data. That would be your Q2, but we don't call it Q2 because it already has a name. It's called the median. The difference between Q3 and Q1, that's called the interquartile range. Inter means between, and quartile are these quartiles. So this is the range between the quartiles. And this shows 50% of your data. An outlier, just so you know, is a data point that is far away from the rest of the data. So imagine having an exam where everyone got 90s and 80s, let's say, and one person got a 50. So that person's grade is an outlier because it's far away from the rest of the data. Specifically, more than 1.5 times the interquartile range from the quartiles. But again, we're not really going to get technical about the outlier, but you should really know what an outlier is. All right, so here's an example that hopefully will clarify what the 5-number summary is. These are some grades I made up. There are 20 of them. So the 5-number summary gives you the minimum, which is the smallest number. I already put these in order for you. So they go from the smallest to the biggest. So the smallest number here, the minimum, would be 45. And let's go to the maximum because that's the easiest to do right now. That's 92. Now the median is the number in the middle. So if I have 10 numbers here, 3, 4, 5, 6, 7, 8, 9, 10 in half of my data, so the median should be in the middle of these two. So the average of 70 and 70 would be 70. That's my median. First quartile is also a median, but it is the median of the first half of the data. So I have 10 numbers here, so my median should be between the 5th and the 6th number here. So I take the average of 57 and 57, I get 57. So that would be the first quartile. And the third quartile would be 3, 4, 5. That would be between 78 and 79. So the average of 78 and 79 is 78.5. So my third quartile would be 78.5. Now the interquartile range, as I was telling you before, is this, right? Because this is your Q3. And this is your Q1. So this is half of the data, the middle half of the data. So the interquartile range would be 78 minus 57, which would be 21. Excuse me. It kind of gives you an idea of how spread out the data is. And that's really all there is to the box plot. Now, sometimes they'll tell you, find the 5-number summary and draw the actual box plot. So you make yourself a number line like here, and you put these 5 numbers on it, and it should look like this. So here's your minimum, that's 45. Then the next number was 57, that's the first quartile. The median was 70. The third quartile was 78.5, and the maximum was 92. So you have, that's how you create the box. So the box starts at the first quartile and ends at the third quartile. And that's why they call this a box and whiskers, because they're calling these things the whiskers. So that's really what it looks like. Now, you could do this by hand, but sometimes you have a lot of data, and doing it by hand and rearranging it by hand could be pretty time consuming, not to mention that you have a chance of getting it wrong. So this is when we're going to have to talk about how to do this on the calculator, or should I say on the calculators. So I'm going to talk about first the 8384. I have the 84 plus here, so it's going to be just slightly different, though I don't think maybe for this part. So if you have a T84 or 83, you could pay attention. Otherwise, you can forward to the other calculator. All right. So I'm telling you to erase all equations from the y equal menu and click Zoom 6 Z-stat. Those are two very important things when you graph statistical graphs. Okay, and you'll see. I'm not going to do that just so you could see what happens. Okay, so to enter your data, you go to Stat, Edit, press Enter, and enter your data in L1. I already entered it here to save time with the video. But you can stop the video and enter the data and make sure that you enter 20 numbers. When you get down to the 20th number, so it makes a lot of sense for you to count your numbers before you enter them in, so you know how many numbers you're entering, because the calculator keeps track of how many numbers. So if you look at, oh, where's my number? If you keep going here, you see how it's, you see at the bottom here, it tells you L1 of 9. That means that this is the 9th number in the sequence. Okay, and we have 20. So we hopefully will have 20 numbers here, 17, 18, 19, 20. It's 20 numbers, right? So 21 is that blank space, but I have 20 numbers. So I'm good. Okay, so now that's the first thing. You have to give the calculator the numbers so it could calculate for you. Next, you have to tell it what you want it to do with the numbers. So we want to get a box plot, which is a graph. And if you remember, when we graphed graphs before, we went to y equals. And they put the graphs for stats also here, but it's above stat plot and it's in blue. So you have to press second and y equals. Okay. And click plot 1. And you have to turn it on. Right now it's off. You see how this is highlighted, so I have to turn it on. And I want you to click, so you go down to type to pick the type. That's a scatter plot. That's not the one we want. We got to keep going. That one has outliers. We're not interested in that. You see those little points there? That means it's got outliers, and we're not doing that. So press that. You should see here X list is L1. That means that's the list where we put our data. Okay. And just press enter, and then you can graph. Okay. Now, I did already, if you see anything else on the graph besides that, that means you have an equation here that you forgot to erase. Okay, so you have to erase all the equations from the y equal menu, otherwise you're going to see all sorts of things there. And you have to click Zoom Stat. Okay, so if you look at the graph now, it's really not telling you any numbers, but if you click trace, then it traces the 5-number summary, so you can check it. So the minimum is 45, just like we got by hand. First quartile is 57, median 70, and third quartile is 78.5, and the maximum is 92. So that's how you do it on this. Okay, now going for the other calculator, let's minimize this. So it's kind of the same idea here. They're very different, the calculators, but the concept is still the same. You still have to enter your data. And this calculator, you click the on button, and then you go to lists and spreadsheets, which is this one. It looks like a box, like a table. So click on that. Now I already entered my data in there. It's right here. Okay. So put all your data in this list. You have to label it X. We have to label it something. So get in the habit of labeling it X, because it'll come in handy in other applications that we'll be doing. Okay, so after you enter all the data, you make sure that you have 20 points, and here they keep track of how many numbers you have. So just make sure you have 20 of them and that they're correctly entered. Most of the mistakes that students make on statistics tests or problems is that they enter the wrong data. So instead of 52, you might by mistake enter 53 or a 5 or who knows what. Okay, so we entered the data, now we have to get the box plot. So we have to go back to the on button and we have to go to the what do you call it, to data and statistics. And what you're seeing here is basically your points that you entered, but the calculator is just throwing them on the screen without any particular order because you haven't told it what variable is what. So you have to go down here and click add variable. And we're picking X because that's where our data is, our list. We named it X. So you have to tell the calculator where the numbers are. So now what you're seeing here is actually a dot plot, but that's not what we're after. We're after a box plot. So you have to go to menu and click plot type and click box plot. And there you go. And again, you don't really see the 5-number summary clearly, but if you hover over these, here's your minimum. There's the first quartile, median, and I got to make this a little bigger. Maximum is 92. So that's how you do it on the calculator. So let's look at a problem here that could possibly be on your regions. Jason saves a portion of his salary from his part-time job in the hope of buying a used car. He recorded the number of dollars he was able to save over the past 15 weeks. Okay, so 15 weeks, so that means that there should be 15 numbers here. I would count them just in case. 4, 5, 6, 7, 8, 9, 10, 13, 14, 15 numbers. Which box and whisker plot represents this data? Well, what I would do first, since it's multiple choice, see, maybe I could eliminate at least one of these. And I'm noticing the smallest number here. These are not in order, so be careful. But I'm noticing that the smallest number is 5. And this graph tells me the minimum is 2, which we know it isn't because it's 5. So this one is out. And the other 3 look like it could be 5. And the maximum here is 19. And they all look like they have 19 as the max. So that's really all I could eliminate right now. So the next thing you would do is you would find the median. So you could do that on the calculator, or you could do that by hand. But first, you have to put them in order, right? So the smallest one, that's 5, and there's only one 5. Okay. What's the next number? Then we have a 6. So cross them out as you do it, so you know that you've counted that number. The next one is a 7. What's the next one here? I see an 8. Okay. And the 9. Oh, I see a 9. 1 9, 2 9s. There are 3 9s here. So that's 1, 2. I think this is not worth putting in the calculator because it's so easy. You just have to take it slowly, make sure you don't make any mistakes. Now remember, there are 15 numbers, so the middle number would be the 8th number, right? So you have the 7 numbers, the first 7, which are these. Then you have the middle number, which is the 8th number, and then you have the remainder 7. So I just need the 8th number here. So what's number 10 looks like it's number 10. Okay, so I don't have to do the rest. This has to be my median because this is the middle number, which is 10. So that would be this choice. Because remember, this line segment inside the box plot, that's your median. And that's 10, and the other ones are not. So that's got to be my choice. Done. Moving along. Here, what is the value of the 3rd quartile in this graph? 3rd quartile is here, so that would be 11. What is the median score? That would be here, and that's 7. And what percent of the values are less than 4? Oh, well, 4 is here. this is my first quartile. Remember, this is the half of, it's the middle rather, the first half of the data. So that means this is 25%. And if you're confused about what I just did, I'll go back to the lesson and show you what I mean. Okay, so here are our numbers, right? This is our first quartile, which was 4. So you see how the quartiles split up the data into 4 equal pieces? So this is a quarter of all of the data. So this was 4 in our problem. So all the numbers for lists were a quarter of the data. And that's it. Okay, good luck.